So question 2, it says that suppose demand and supply are given by QD equals 60 minus P and QS equals P plus 20. The first thing you want to do is you want to graph each of these. I'll do that in another window, and then I'll snip that in because we'll want to look at that together here.
Is there any shorthand for price floor, like P of X?
Like you can, I mean, kind of. I mean, once you know like what the scenarios are, it depends on whether the price is above or below the equilibrium, and then it furthermore depends on whether it's above or below. Sorry, do I have these backwards?
Yeah,
I do. Wait a second. Is that really right? Q? I thought it isn't price on the y-axis.
yeah. Price is on like the left.
So
Like
why did they give them to you this way? Okay, so we should solve for P for both of them. So that will help a lot better. So P is let's see, 60 minus Q. And I mean, it doesn't change anything actually, but and the other one is P equals Q minus 20. So I guess it does change slightly. Okay, let me go grab this. Go grab this other picture. Okay, so 60 minus X. Okay. Okay, so price is here, Q is down here. They intersect at 40, 20. Okay, and then the question asks, you've got it on your screen too. It asks, actually I don't have it up anymore. It says if a price floor of $50 is imposed in the market. So it's a good idea to draw that price kind of across here until it hits both curves, which I don't have enough room, but I'll get that. I believe it's at 70. Let me grab that here. Yeah, it is at 70. Okay. So the question is whether the price is binding or not. And do I need to explain that, or is that something that you guys have been talking about in class?
Can you go over it? I'm not sure.
So the equilibrium price and quantity is 20. Like you as a buyer expect to pay 20 in this market. So if someone tells you you're going to pay 50, you're like, why would I do that? Because like you'd rather pay 20. So it's binding because the price is above the equilibrium price. Like,
Okay.
let's just say it's something you had to have. Like, let's say it's I don't know, an Uber ride home. You're not going to walk, so you just pay the extra that's in there.
Okay.
But let's say the price. So the price floor means it's a minimum. It's the least you can pay. Okay, but if the minimum was below the equilibrium minimum, well then you're going to pay the equilibrium price.
Okay.
And so there's like 4 situations. There's 2 for the price floor, one where it's above and below the equilibrium, and then there's a price ceiling, which is above or below the equilibrium, and depending on the situation, you can't pay more than that. So like the more common example is you're in New York City, and that's the price of an apartment. Well, they set a price ceiling right here. That's less than the equilibrium price. They say to the owners, like, you cannot charge more than this for the apartments. And they're like, well, we want to, because the equilibrium price is way up here. Like we should be able to charge, let's just say this is 800 and this is 1,000. It's probably off by an order of magnitude, but New York City, but let's just say that for reasonableness, that but they're stuck. They cannot charge more than that. That's a binding price ceiling because it's below the equilibrium price. Okay. But let's just say in another scenario, you got an Airbnb and the market says it's $100 a night, which probably is still low. But the price ceiling is $150 a night. Nobody cares what the price ceiling is because they're just going to pay the equilibrium price. So when it's above, it's not binding.
Correct, that makes sense.
Okay, so for a price floor, we just did two of those examples, but for a price floor, if the price floor is above the equilibrium, then it's binding. Because the market wants to pay the lower price, but they're like, they can't get there.
Yeah. Okay, that makes sense.
And if it's price floor is below that, they're still gonna, that the last one is price floor is down here. That's the minimum anyone will pay, but it's not binding because nobody cares because it's below what you're going to pay anyway in the market. So the only two that you really need to know that are binding are the ones I'm gonna the ones in red here are the important ones. When it's the price floor is above and the price ceiling is below. Those are the only two binding ones that you have to like get down.
Okay.
Okay, so now we can get to the actual surplus. So, and we'll actually answer your question in a moment, but I want to, there's like a lot that goes into it. So when you have supply and demand, your surplus is this triangle over here to the left. These two triangles. Have you seen that before?
Mm-hmm. One's producer and one's consumer. Right?
Yeah, producer surplus, consumer surplus. So in the case of the scenario that we talked about from the beginning, which is, let me go back and grab the graph. Yeah, let me just reframe this slightly. And it's kind of awkward because it's solved for the wrong variable. I don't know if that was intentional or not, but this is where they intersect. So the consumer surplus is this upper triangle. Okay, the area of this upper triangle. So the consumer surplus is 1/2, the base is 40, and the height is 60 minus 20. Okay, which is 800. Okay. The problem is that when you are forced to charge this price in red, your consumer surplus shrinks down to this triangle up here. So your new consumer surplus is 1/2 your base, which is 10. That's the price. And your height 60 minus 50. So it shrinks down to almost nothing.
And this is for
that's your actual problem. That's the one that you're
red triangle.
Yes. Yes.
Can you go back over that one more time?
Yeah. The black triangle is the like the regular consumer surplus they're used to when you're at market.
Like
price.
equilibrium?
Yes.
Okay.
Yeah, and that's like ideal. But what we're saying is like You can't charge that price. You have to charge this price of 50. Okay.
Uh-huh.
And and that means that the triangle gets smaller, a lot smaller, in fact. And so your area of your new triangle is much less than the area of the big triangle. You're cutting it out up significantly.
Okay. All right, and that's the answer is 50. Like the full answer to the question.
Yeah, let me look again at the question. Yeah, surplus that occurs. So so what here's what I guess I don't know for sure is you lose. I don't know if you get all this. And the other thing is weird is because it's down here in the negative, but your consumer surplus is significantly reduced and your producer surplus, I believe is also cut down here. And what's in this middle region is I think referred to as dead weight loss. Oops.
Oh yeah, yeah, we did go over that yesterday.
Yeah. So this in here is like everyone's a loser because they don't get what they're supposed to.
Okay, I believe she's looking for the answer with the producer surplus as well.
Okay, so we would just add this other triangle down here, which is the same area.
It's like the
blue triangle.
But is it just double at that point?
Yeah, most of the time. Most of the time, yeah. I mean, it depends on the slope of the curves and things like that, but yeah, for this one it is.
Okay. So the answer would be 100.
Yes.
Cool. All right.
Let me just check on this. Got where I images. Yeah, I think this picture is a good one for us to look at, just to kind of. It's essentially what we just did. So let me snip this in. This minimum wage is the one that often comes to mind. The market only wants to pay $4 per hour. This is obviously a pretty old thing, and people want minimum wage to be $5 an hour. Well, the problem is that it cuts into this triangle up here that you normally have for consumer surplus, to this much smaller triangle.
Oh, okay. Okay, I see.
Okay. And the shading really helps here. They call this the dead weight loss. I don't know what this middle region is, but it's not surplus. It's sometimes called the tax, and in other problems it'll be your taxation to government. But
yeah. No, actually, yeah, where they have it is like now. I just went back a page. Yeah, that's where my teacher did put the dead weight loss.
Okay.
Yeah, and that like triangle. Okay. Yeah, the other thing isn't. I don't see any markings for that. For kind of like the pink area, like potential loss from job search.
Yeah, it's yeah.
Okay. All right, that makes sense though.
Okay. Question one is more of a, we have to go back and grab it if we want to go through that. That's more of just an essay type question. Let me.
Yeah, could we go over it just so?
Yeah,
it's what we kind of started off.
I'm gonna have to look up some definitions here to help here.
Is it because that's kind of like the equilibrium, right? Cause like marginal is like your most recent unit. So when that's 0, it's kind of when your production's at like its most efficient.
Yeah, so if we were to graph benefits on some sort of curve, there's two possibilities here. Either the curve goes like up and down, and right up here, marginal benefits equal 0 because it's the tangent curve.
Mhm.
Or I don't know, I actually don't know what shape this goes, or if it comes down like this, marginal benefits are 0 down here. So let me go look at that.
Oh, so it can be like the lowest point as well.
Yeah. Yeah, so the first curve is I guess more representative of what you see in textbooks.
Okay.
So the idea is like let's pick so you're going on a vacation.
Mhm.
Sounds like, okay. So we'll just use that as an example. So your benefit versus time. So like day 1 of your vacation, you are like, I love this. Actually, that's probably a little, we'll see if we can, but you probably really enjoy that first day of vacation. The second day, you probably don't enjoy as much. Maybe that's not true, but let's just say it's not quite, you still enjoy it, but it's not quite as much. Okay. And then third day, you still have a good time, but maybe not as much. But at some point, we'll just do it here. At some point, you're like, yeah, I gotta get back to school. You know, I miss my mom, miss my girlfriend, whatever. Like at some point, you're like, yeah, I don't really want to be on vacation anymore.
Mhm.
And so this total benefit curve, they call this the total benefit curve. At some point, it peaks, and that's where the marginal benefit equals to 0. If you don't like the vacation example, we could use, eating, drinking alcohol,
No, it makes sense. I had a
whatever,
teacher
whatever it
kind
is
of,
that, whatever it is, like at some point you're like, yeah, I don't need to keep doing this thing over and over again. Studying. I mean, you can even use studying, which I mean,
yeah, my teacher, yeah, I can't remember like the exact way they explained it, but it was something like at some point there's like like where you start getting like less return for something. Yeah, like when you're the hungriest, like the first slice of pizza and then the second
yes,
one, but then
yes,
eventually like it makes less of a difference in your hunger and then you're not hungry anymore.
right,
It's like doing a negative.
right,
Yeah.
right.
So,
So the marginal benefit switches from being positive to negative at this peak. And that's key. That's really key.
okay, that makes sense. I was just writing that down.
Okay.
Cool. I think that's mostly it for econ.
All right.
Wanted to get that out of the way. And then just spend time with yeah, just anything you have on like multiple regression. Like I sent you that thing and then just kind of what makes sense off of that, I guess.
Yeah. There's some problems here we can look at if you'd like.
Yeah, there is actually, yeah, I forgot about, there is one thing, like he generally like the kind of like the last time he had like a main example to go through. I believe it's assignment 4. I don't think I actually wrote it down, but it's assignment 4, I think on it.
Yeah, got it. Okay, so my question for you is do you want us to go through this first example like in Excel? Do you want to see how to do this in Excel?
Yes.
Okay. All right. Should I do this? Okay, let me, I'll switch to an Excel window after I grab the data. Okay, so let's go new Excel window. All right, so I'm going to share this Excel window. They want you to enter Y is your profit, X1 is your capital, X2 is your advertising. The order does not matter, but the X variables do need to be next to each other. Like you can't put Y like right in the middle. So I'm just going to enter the data here. If anyone ever gives you a data set, it's always better to get it electronically. Like what I'm doing is very inefficient. I mean, it's fine for this format, but if it was really important,
Oh, like especially when you're on time and stuff.
yeah, I would just reject. I mean, in the workplace, I would just say, no, I need, I need the data set because here I've already messed up here. Oh no, 6 and 16. I guess that's okay. I mean,
Okay, yeah, I see what you're saying now.
they used to pay people just to enter data. Maybe they still do. Horrible job.
Yeah, like I mean, I work for my mom just because I can do it based around school, but like half the shit I do is data entry.
Yeah, it's awful. It's really awful.
It's not fun. Yeah.
Yeah. So there is the thing in Excel that you need to go down to options. You need to go to add-ins. And you need to enable this analysis tool pack. I think you do it under manage Excel add-ons.
Okay, I think I've done it, but I'll make sure.
Yeah, that if that's not there,
That's the only one you need because the other day I think can you have the VBA one enabled as well or no?
probably.
Okay, I enabled that one the other day, like looking for something, but I think it was just because my screen was too small.
Yeah, yeah. So then you go to data analysis. And you have to choose. I mean, there's a lot of these, depending on the courses you take, you may actually use all of them. It's not correlation, it's regression, or is it multiple regression? Let's go regression, see if that one's right. I can't remember. I don't do this here very often. Why is it complaining? Okay, your input range. Your input range is Y. So we're going to select the Y values.
Oh.
Your X's are these X1s and X2. So select those. You can hit enter if you need to. We do have labels. And then the next thing is like where to actually put the output. So most of the time you're going to do it in a new worksheet, and you can either name it if you want. You can call it output or problem 2 or example or whatever you want. Sometimes people like to have it in the same sheet. That's when you use the output range. You almost never select this other stuff unless like you need something from it. There is an argument to be made to like selecting confidence level, residuals, all this other stuff. Not the constant is 0. You rarely do that because you can't actually go back and edit this. Like once you do it, you're stuck. Okay. So here we go. This is the output. And let me go check and see if we got some similar stuff there. 0.9825. Huh. Oh, they guess they don't give you the they don't give you the output to know if this is right. So, but this is how you do it. I mean, this is it. The data values you care about, you're going to want like this R square will be of use to you at some point. This F value and the significance value will be of use. Sometimes they want some of this ANOVA table, but then the last thing that you really will need are this stuff here. And so the more you do this kind of math, the more you'll need some of this other stuff in there. But basically just these values. So part A asks for the least squares prediction for these data. So I'll do it on this screen. A is y equals, and you take your intercept plus, we'll do it like this, the x1 value coefficient. So we'll go grab that. X1 plus you grab that next value. No, this isn't all that like it's not squeezed together nicely, but that's your equation. Y equals this minus 8.177 whatever plus 0.292 times x1 plus 4.34 times x2. That's your equation. That's part A.
Okay.
So part B, they're telling you that they invested $24 million. Okay, so that's X1. They're saying X1 is 24 and 6 million on advertising. That's X2. And they say it's that the units are in millions of dollars. That's why it's 24 and 6. And so you have to figure out like what is the output here. So you take the numbers and you work out this equation. So I'm just bringing them down. Oops. Okay. So you're in terms of the result here, you're going to take this number, you're going to multiply that number times 24 plus this 4.43 times 6. And it's 25 million. Since that is greater than the 20, which is indicated in the problem, yes, a bonus.
Okay.
I mean, you could write out this equation by hand. I'm just using Excel, so I don't have to copy the data, copy the numbers. But you would obviously write it out, and get some sort of a this. Okay. So now part C here. Let's see what part C says. So it's doing the same thing again. It's just saying for Big Daddy, .gon, and Ubay, here's some things. Do they actually get a bonus? So do you want us to do those?
Yeah, can we?
Yes. Okay. So let me do it slightly differently now because this is becoming a bit awkward. So let's do so for part C, let's do so we'll do company, and we'll do big. What is it? Big Daddy.
Doggone and Ubay.
Doggone and Ubay. And then we just need the numbers for each. So 62, 3, and 45. If you can read those to me, 62, 3, and 45.
Oh yeah, and then the 70, 43, and 30.
Okay.
And then 3, 1, and 1.
All right. So this is the capital, this is the advertising, and this is the profit.
Or
Okay.
lost. The last one was technically lost. Like Ubay lost.
Okay, so was it -1 then?
Just said actual. Yeah, actual loss is 1 million. So I guess that would be -1.
Okay. Well, sure. I sure hope they're not giving out bonuses and losses. So now we're going to do our y equals, our projection. So you take this number you just found times the capital investment. Hopefully you can see that, C6 times that coefficient.
Okay, yeah.
Okay, but you need to hold it because you don't want to have to redo this formula each time. So F2 helps you to hold it. Why isn't that working? Oh, that's why. No, it's F4. F4. Why is this string? Okay, so the other way is to use the dollar symbol and you hold it that way. So plus, you take your advertising dollars and you multiply it by the advertising coefficient, but you want to hold the cell for the next calculation. So that's why I use the dollar symbol. And then you add the intercept there to it. So there's your regression progression equation.
Okay, that makes sense. Oh, for hold it for the next cell, what do you mean? Like I remember that I lose this
So
stuff.
so I can drag it down now. Let's drag it down to the next one. And when we look at this formula, see how it's still, well, actually, why didn't it be? Okay, so it's using, oh yeah, it is using, okay, I just can't see it. Sorry, just trying to, oh, and the Zoom isn't real good on this. Apologize, forgot about that. So when we look at this one, it's using this cell B18 and B19 and these two. And that's why you hold it. And then when you drag it down again, you get the same thing. It's using, you know, B18 and B19 again. You don't have to manually type them in. You can do this by hand though. Like this is not this is just an Excel thing to know about, just to save us time. So in the first case, there's no bonus because it's not bigger than the 45. This case, there is yes bonus because it's greater than the 30. And this is yes bonus because it's greater than the -1.
Okay, that makes sense.
But all we did in this table is just sort of automate like the calculations we were doing up here in the previous ones. Okay, so do we need to do VMail, UPod, and iTech?
No, those made sense. What you just did was pretty clear.
Okay, I'll just comment that for VMail, UPod, and iTech, you have to convert to millions. So like 800,000 is 0.8, and 1.1 billion is 1,100, and 4 billion is 400. You have to do some unit conversion there.
Okay.
All right. So the next problem, do you want us to go to the next example or go to the assignment?
Can we go to assignment 4?
Yes.
Yes.
Okay, assignment 4. It says the table below lists the analysis of a sampling of residual sales in Eugene, Oregon by the Lane County, et cetera. Okay, they're just trying to tell you what all the variables are. So they're looking at homes. The first variable is square feet. Second variable is number of bedrooms. Third variable is number of bathrooms. Total rooms X4, age of the house. And then these last two, they only take on the values of 0 and 1. So they're binary variables. Okay. Sometimes they, like, if it has a pool or doesn't have a pool, you know, they can't be halfway. You either have it or you don't.
Okay.
And then the problem moves on to giving you the regression information. And boy, aren't they kind of jerks. They don't give you some of the things that you need. So there's a lot here. I'm sorry about that. You are seeing. Did I share back to this other screen? Maybe I didn't.
No, sorry. I am seeing
Okay,
like yeah,
now it knows. Okay, so you're seeing what they're missing. What they did not give you is the degrees of freedom for the regression and the residual, and they obviously didn't give you these. I don't know why they didn't give you the degrees of freedom. They should have, but if you go back to, let me go, I actually do have to go back now to that other screen, the Excel, so we can see this. So if you go back to this, there, the regression had 2 degrees of freedom. The reason it had 2 degrees of freedom is it's 3 minus 1, which is 2. Basically, I guess you could just think of it as the number of variables in your regression. That's probably easier. The total is also probably easier to explain. The total is the number of samples in each minus 1.
Okay.
So there's 10 here. 10 minus 1 is 9. And then the residual is total minus regression.
So is it 7?
Yeah, so in our problem,
For total?
what I need, yeah, in our problem, let me go back to the other screen. So we have 7 variables. So the regression is going to be 6 for that one. But for the 50 single family residents were surveyed. So it's 50 minus 1, which is 49 is your total. And then you subtract the 2 to get 43 in here. You have to do degrees of freedom first, though.
Okay, hold on. Why was it 6 again? Because it's
Oh,
like
sorry,
total number minus 1.
sorry, it's 7. Sorry, it's 7. It is 7 because it's number of
Oh.
variables. Sorry, so that changed that to 42.
Okay.
Okay, now means MSR is, and this is called a sum of squares. It's SS divided by degrees of freedom. So the number in this question mark right here is 3483.183 divided by 7. It's always divided by the degrees of freedom. That's why we needed to get the degrees of freedom first. So let me grab a calculator. Okay, so that's 497.60, and these numbers don't mean anything, so there's no way to know like if it's right or wrong. I mean, that's why you let the computer do it. The mean square error, same thing. You take the sum of squares and you divide it by the degrees of freedom. So you take this other sum of squares, 379.291 divided by 49. So that's 7.7406. And then your F value, your F is always mean square regression over mean square error. So it's an F value, 64.284. Because you definitely got to know these formulas. But if you're just doing it in Excel, they give it to you. So maybe that's not true either. Hard to say because I don't know what the format of your exam is going to be. The other thing, so that's kind of part A. Kind of. We didn't do everything in part A though. But any questions on that?
No, that makes sense.
Okay, so part A wants the MSR, MSE, and F ratio. Check, check, check. Now we have to figure out whether it's significant or not. And to do that, we have to look at the p-value, which we were not given. So we have to calculate the p-value. The p-value is based on the F value right here and the degrees of freedom. So there's this F table where you can look up the degrees of freedom. You can also do it in Excel. So I guess we'll just go right to back to Excel and do that to get that number. So there's a couple of ways to do it. One way is, and I'll just show you here. So you take you do F distribution, and you want the right tail. It's always a right tail test. So your X value is this F value that you calculated. Your degrees of freedom 1 is the regression. Your degrees of freedom 2 is the residual, close parentheses, and you should get 0.02332064, exactly what we got in this problem. But for you, your degrees of freedom are slightly different, and your F value is slightly different. So we're just gonna replace those values. I'll just grab this formula. Well, actually, I'll just type it again. So your F dot distribution at right tail, your X is 64.284 comma 7 comma 49. And so it's basically 0. E to the minus 22 is 0. So we can now go back and answer that first question. So if you recall from your statistics course, since or if the p-value, which in your problem at 0 is less than alpha, which in your problem is 0.05, you reject the null hypothesis, and that means that the model is significant. It's just a rule. If your area, your p is less than 0.05, it is for sure a significant model. All right, part B. What proportion of the variation of residual sales is explained by the 7 predictor variables? So this is just a number you're going to look up in the model. So here we go. You're looking for the R-square value.
Okay.
So you would say 90.06% of the variation in sale price is predicted by the 7 variables, which is pretty good. And that's pretty good.
It's predicted by the sale value.
No, the 90% of the variation in the sale price, or the value of the home, is predicted by these variables. And what that means is that those 7 variables tell you 90% of the reason for the sale price. There's some other number of variables that contribute to 10%, but these are like really good because they tell you 90% of the variation. Variation isn't really the right word, but it's 90% of like how well it predicts the output.
Okay.
All right, so C is the regression equation. So we have to go back to the model here. We're going to look at the next part of it. So this is your regression equation, this column right here. But the constant is the constant, but it's this one times x1, the next one times x2, the next one times x3, the next one times x4, the next one times x5 times x6 and x7. And so you have to write that horrible all this out, this plus 1.0207 times x1 plus 1.6270 times x2 and so on.
think I'm a little confused on that.
You're
Alright.
just, like the table gives you the coefficients. The table tells you what the coefficient is in the multiple regression. And you multiply the number in this column by the variable. Remember back up here, it said, the variables are x1, x2, x3, x4, x5, square
Mhm.
feet, bedrooms, bathrooms, and so on. Your equation for predicting the price is this constant number plus 1.0207 times the number of square feet in the home, plus 1.627 times the number of bedrooms, minus 3.85 times the number of bathrooms, and so on.
And so it's just asking for the equation.
That's it.
Okay.
That's it. That's all it's asking for.
Okay, so I was like, oh, that makes more sense. I was like, okay, then like, how am I finding X1 to get the answer? But it's not asking for that.
No, it'll give us that probably in the next question. It'll say if x1 is this.
Okay, so that makes sense. Just putting it in my notes now. All right.
All right, probably just stop here and pick up in 10 minutes for our 10 o'clock and just continue with that. So just please use that other Zoom link and I'll see you in about 10 minutes.
Okay, perfect.
All right, thank you.
Thank you.